Hey everybody, so the combined gas law is where we're at now with the laws that we've been covering. Just to recap, here's Boyle's law and here's Charles' law, and the thing I want to point out with the combined gas law is if you look at Boyle's law, remember I said that Boyle's law is a gas that's under constant temperature. And for Charles' law, it's a gas that's under constant pressure. And so you can see that in this formula there is no temperature variable, and you can see in this formula there is no pressure variable. But if we were to combine these two gas laws, so unsurprisingly enough, that gives us the combined gas law, where no conditions are constant. Pressure, temperature, and volume are all variable, and we need a formula to show that. And so we just take those two formulas and combine them together, and it looks like this. And so you can see, again, that pressure and volume are inversely proportional. As this one goes up, the other must go down. And volume and temperature are directly proportional. As volume goes down, then temperature would go down, and vice versa. And so there's the formula. Now here's an example to just kind of illustrate how to use this formula. We've got a weather balloon that's at 20 degrees Celsius, a pressure of 100 kilopascals, and a volume of 7.5 liters. Those numbers are all there. This is in obviously Kelvin, because again, this formula, combined gas law, is related to the Charles law formula. So these temperature values need to be in Kelvin. And then we've got a final pressure and a final temperature there listed as well. And we're looking for V2. So solving for V2, we need to get V2 by itself, which means I need to times this side by T2, because I'm dividing by T2 here to get rid of it. And I need to divide by P2. So those can cancel out like that. And so what I do to that side, I have to do to this side. So T2 would go on the top here, and P2 would go on the bottom. So V2 is going to equal T2 P1 V1 divided by P2 T1. And then once you've got this formula set up like this, then you can just take those numbers, plug them into their corresponding spots, and plug those into your calculator, hit enter, and you'll get an answer. So it looks something like this. My T2 is 237 Kelvin, P1 is 100 kPa, and V1 is 7.50 liters. Notice that I'm putting the units in. That's really important that you're putting the units in while you're doing these problems. P2 is 28 kilopascals, and T1 is 293 Kelvin. I plug that into my calculator. Again, you can see the kelvins cancel, the kilopascals cancel. I'm left with units of liters, so that means that my answer is going to punch out as liters, and I end up with 22 liters. Notice that this is to the correct number of significant digits, because my number here, 28 kilopascals, is only to 2 sig digs. This number here is to 3 sig digs, this is 3, and again, remember, we're ignoring the temperature numbers in terms of determining significant digits. And so there it is, 22 liters. And that's it, guys, for this one. We'll catch you in the next video.